The US Navy has always had a messy problem: fouling. This is when algae, barnacles, and other sea gunk cling to ships and submarines. It slows them down, wastes fuel, and makes them easier for enemies to detect. For years, engineers tried to stop fouling with toxic metal coatings. But these coatings lost effectiveness and harmed the ocean. So, the Navy turned to materials scientist Dr. Anthony Brennan for help. Brennan was studying how surface textures affect organism growth. Algae always returned, until a trip to Hawaii changed everything. At a marine conference, Brennan noticed manatees and whales were grimy, but sharks were perfectly clean. Not one barnacle, not one streak of slime. Intrigued, Brennan and his students took a harmless dental mold of a shark's skin. Under a microscope, they found the shark's surface was covered with microscopic, diamond-shaped scales called denticles. These tiny ridges created a texture that physically prevented microorganisms from attaching. As a microbiologist, I find this fascinating because hospitals have their own version of fouling. Bacteria latch onto medical devices, forming biofilms that resist antibiotics and prevent healing. One patient's chest wound refused to close until infected wires were replaced. Antibiotics once seemed like magic, but bacteria evolve fast. Each exposure drives new mutations, leading to antimicrobial resistance, a major public health threat. In the US, 2 million people get antibiotic-resistant infections each year, and over 23,000 die. The pharmaceutical race to outsmart microbes is unsustainable. What if, instead of killing bacteria, we made it impossible for them to stick? That's the idea behind Sharklet Technologies, a company Brennan co-founded, and the team I joined in 2013. We engineered surfaces that mimic shark skin, using its micro-pattern texture to repel bacterial attachment. Our first product, a urological catheter, is already in hospitals. Under the microscope, smooth surfaces swarm with bacteria, while sharklet textures remain nearly spotless. The key lies in surface energy, how a material's texture affects interactions with water, cells, and microbes. Like rain on waxed car paint, shark skin structure changes these surface interactions, no chemicals required. This approach doesn't just stop infections. It can reduce blood clotting, clogging, and improve device integration. By tuning microscopic surface energy, we can make medical implants safer, cleaner, and longer lasting, inspired by nature. It's a simple lesson. The solution to advanced medical problems isn't always a stronger drug, but learning what the shark has known all along. Thank you.